Okay, so this video is going to cover circles, chapter 7.1 through 7.3. And by the end of this video, you should know all of the important vocabulary and some important properties of circles. So, a circle is the set of all points in a plane at a given distance from a given point in the plane. So if we have a point, and then we have a distance, like here, and then we have all the points that are this distance away from the center point. So this is our circle, and then this is our radius, and this is our center. So in essence, the radius is the segment from the point on the circle to the center, and the center is this given point, and it also names the circle. So congruent circles are circles with the same radius. We have two circles, and we say that they both have the same radius. They're congruent. Concentric circles are a little different. We have a center here, and then we have one circle going around the center, and another circle also going around the center, and they're in the same plane. Those are concentric circles. So concentric circles are coplanar circles with the same center. So to find the arc of a circle, you take a circle, and you find 2 points on that circle, and then the continuous part of the circle between those 2 points, that's the arc. And then the endpoints are these 2 points at the end of an arc. A semicircle is the arc of a circle whose endpoints are the endpoints of a diameter. So if we have a circle, and the center's here, and we have a diameter going all the way across the circle and through the center, then a semicircle has the endpoints here at the end of the diameter, and it's here. So without all the other stuff, a semicircle looks sort of like that. A minor arc is the arc of a circle that is less than a semicircle, so it could be like that, or like that. And a major arc is an arc of a circle that is more than a semicircle, so it's going to be more than 180 degrees. It's going to be something like that, or almost a circle. A chord is a line segment whose endpoints lie on a circle. So again, if we have a circle, then the chord is going to be a line segment like that, whose endpoints are on the circle. And then a diameter, as I mentioned earlier, is the biggest chord of a circle, and it goes through the center. So if we have a circle, and we have the center here, then the diameter is going to be the chord that goes through the center, and it's the biggest chord you can make in a circle. A secant is a line that passes through a circle at 2 different points. So if we have a circle, then the secant is going to be a line such as this one. And as we can see, it passes through the circle here and here. A tangent is a little different. It passes the circle exactly once. It touches the circle at exactly 1 point, so it would be a line like that. And it touches the circle right here. And the point of tangency, pretty self-explanatory, is the point where the tangent touches the circle. So an inscribed angle is going to be the angle between 2 chords. So essentially, it's made of 2 chords that share an endpoint. So if we have one chord here and one chord here, and they share this endpoint right here, this is an inscribed angle. And then a central angle is a little different. We have a circle, and we have its center here, and then we have 2 radii, so they go to the center. Then this is a central angle between 2 radii. So our first conjecture says that if two chords in a circle are congruent, then they determine two central angles that are congruent. So if we have our circle in our center here, and we have two chords that are the same length, like that, then from the radius to each of those chords, this angle is going to equal this angle. Sorry for the drawing. And then our next one says that if two chords in the circle are congruent, then their intercepted arcs are congruent. So this means that this arc of this chord is equal to this arc of this chord. And then our last conjecture here says that two congruent chords in the circle are equidistant from the center of the circle. So that basically means that this distance is equal to this distance. So our next conjecture says that the perpendicular from the center of a circle to a chord is the bisector of the chord. So if we have the center here, and then we have a chord here, then the perpendicular line that goes from here to here, the perpendicular, is going to also be the bisector of the chord, so these two parts are equal. And then this next one says that if we have a circle, the chord, then the perpendicular bisector of the chord passes through the center of the circle. So this goes along with the other one. Basically, if we have this line that bisects this chord and has a perpendicular angle, then it's also going to go through the center. So tangent circles are circles that are tangent to the same line at the same point. And there are two different types of tangent circles. They can be internally tangent, in which, so we have our line, and then we have a circle that's tangent to it, like that. And then we have another circle that's tangent to it also, and as you can see, one is inside the other, so we call that internally tangent. But they're tangent to the same line at the same point. Then we have externally tangent circles, where we also have a line. Sorry, that's a little wiggly. And then we have one circle tangent to it here, and another circle tangent to it at the same point, but on the other side. And that's externally tangent. So this conjecture, the tangent conjecture, says that a tangent to a circle is perpendicular to the radius drawn to the point of tangency. So we have our line, and we have our circle, which is tangent to the line, and we have the center. Then the radius here is going to be, to the point of tangency, is going to be perpendicular to the line that's tangent to the circle. So tangent segments, probably not a term you'll hear that often, but it's just segments, line segments that are tangent to a circle, and they can form angles and stuff like that that could be important. So, for example, here in this next conjecture, tangent segments to a circle from a point outside the circle are congruent. So in this picture I just drew, these two tangent segments are going to be congruent.